This video introduces how to execute a pick and place process for neatly arranged housings, as shown. To achieve this, make sure to complete preliminary work first, including vision system hardware setup, robot communication configuration, hand-eye calibration, and target object configuration. In this video, we will build a path planning project by using the path planning step in Mech-Vision, and then configure the pick and place program for the robot to achieve picking. To avoid collision, the operational steps of picking and placing are set as follows. Move the robot to the initial pose. Move the robot to image capturing pose and get planned path. Perform picking according to planned path. Perform placing. In the second step, the robot needs to get planned path from Mech-Vision by standard interface communication. The path planning step in Mech-Vision has the following functions. Plan the picking path for the robot. Detect the collisions among the robot, the scene objects, and the end tool. Simulate the robot's picking process. Thus, let's begin with configuring the path planning step in Mech-Vision to preview the picking path of the robot. The workflow of configuring the path planning step in Mech-Vision includes tool and scene objects configuration, workflow creation, and simulation. Now let's begin with the specific operations. In the solution of loading neatly arranged target objects, navigate to the step of path planning. Click Config Wizard to enter the tool interface. First, configure the end tool. Add the tool model in OBJ format to the model library. Enter the information in tool configuration and set the TCP. The TCP should be adjusted to match the actual tool center point. Please make sure that the TCP set here is the same as that of the actual tool. After configuration, activate the tool. Next, configure the scene object. Add the scene object's STL model and adjust the model's pose. Add other scene objects, such as the pallet, to make the scene in the software closer to a real-case scenario. Now we will proceed with building the workflow for future path planning. There are 5 steps in total. First, move the robot to image capturing pose, which refers to the position where the robot captures images. At this position, the robot arm should not block the camera's field of view. Record the robot's pose in the workflow. Second, plan the approach waypoint of picking. Third, plan the actual pick point. Fourth, plan the retreat waypoint of picking. Fifth, move the robot to the intermediate waypoint. Record the robot's actual position in the workflow. Please note that the first step and the last step are only for simulation. In this way, the workflow has been built. Now we can click the Simulate button to simulate the workflow of the virtual robot. The simulation should be performed 3 times. The target object should be rearranged after each successful picking. If all simulations proceed smoothly, the vision project can be used for the robot to perform picking. Now we have completed the configuration of the path planning step in Mech-Vision. Next, we need to configure the program for the robot. In this video, we use a KUKA robot as an example. The example program we use is from our software. Please operate your robot according to actual use. Here are all the steps of the robot's pick and place program. First, set the tool frame. Make sure that the TCP of the robot's tool frame is the same as that in Mech-Vision's path planning step. Modify the tool frame number in the robot program according to actual use. Next, teach initial pose. Move the robot to the initial position, which should be away from the objects to be picked and the surrounding devices, and should not block the camera's field of view. Teach the initial position in this step. Then, update the IP address in XML file corresponding to the init socket command, to the actual IP address of the IPC. Afterwards, go back to the example program, and teach image capturing pose. Next, the robot will get the planned path from Mech-Vision, and save the acquired waypoints of the planned path to local variables. There are 3 waypoints in total: the approach point, the pick point, and the retreat point. Next, move the robot through the approach point to the pick point. After approaching the pick point, set DO to open the gripper to pick the workpiece. Please modify the general output signal ID according to the actual situation. Next, move the robot to the retreat point. Then, move the robot to the intermediate position and the placement position. Record the poses respectively. After approaching the place point, set DO to close the gripper to perform placing. In real application scenarios, please modify the general output signal ID and state according to the actual situation. So far, we have completed the configuration of the pick and place program for the robot. Now we can run the program to test the pick and place performance of the robot. We can add loop statement in the program when multiple pick and place tasks are required. These are all the steps for picking and placing neatly arranged housings. You can refer to our example programs and documentation for more information on complicated pick and place scenarios and the operation of other robots and PLCs.